Welcome to this video, which is the full solution to the practice questions from lesson 24, intersection of three planes. In this question, we're asked to determine the relationship between the following planes, and we are going to use augmented matrix to do this. So we're going to start with part A, and we're going to try to get the echelon form of the augmented matrix in 3 steps. For the first step, we will simply just write all the values here. So for the first one, the coefficient of x is 1, -1, and 2. Of y, we have -3, -11, and 8. And for z, we got -2, -5, and 3. And our constants are 9, 5, and 4. Once we have this, we can go ahead and start reducing the values for coefficients of x in the second and third row. And to do this, we're going to keep the first row as is. So 1, -3, and 2. And for row 2, we are going to just add the first row to the second row, and that would get rid of the x component, or make the coefficient of x to 0. So that's row 1 plus row 2. And I'll just read them out. 1 minus 1, 1 plus -1 is 0. -3 plus -11 is -14. -2 plus -5 is -7. And 9 plus 5 is 14. For the third row, we can use either row 1 or row 2. So let's use row 2 in this case. We are going to multiply row 2 by 2 and add it to row 3. I'll write the values here so you folks can follow. 2 times row 1, we will get -2 for x, we will get -22 for y, -10 for z, and 10 for the constants. And we're adding row 3 to it, so I'll just add 2, 8, 3, and 4. Once I add all the components, -2 plus 2 is 0, -22 plus 8 is -14, -10 plus 3 is -7, and 10 plus 4 is 14. This is nice because we can see that these row 2 and row 3 are exactly the same, so we can add them up to reduce this row to 0. So let's do that. We got 1, -3, -2, and 9. We got 0. And basically, I'm going to change row 2 as well. Row 2 is going to equal to row 2, the previous one, divided by 7 to reduce it a little bit, actually -7. And here I will get +2, I will get 1 here, and I will get -2 here. And you can see I did that just to simplify the numbers a little bit, because it's harder to deal with larger numbers, especially when you start multiplying it and dividing it by different values. For our last row here, row 3, it is going to equal to row 2 from the last step plus row 3 plus last step, and that's going to give us 0, 0, 0, and 0. At this step, we can see that our last row has been reduced to zeros, all zeros, and our second row isn't, and this pretty much represents the fact that these three are intersecting at a line, so the three planes are intersecting at a line. So let's figure out the exact equation of the line. We're going to start off with the first line over here, or second row over here, and we'll write that equation down. We get 2y plus z is equal to -2. And this tells us the relationship between y and z, but if we want to write this in a parametric form or vector form of a line, we need to let one of these variables equal to t. It doesn't really matter which one we let t in this case. I will let y equal to t, and then we will have 2 times y, which is t, plus z is equal to -2, and that would mean that z is equal to -2 minus 2t. And now we have a relationship between y and z in a parametric form with respect to t. So, for our final parametric form, x, y, and z, for the y value we have it as t, and for the z value we have it as -2 minus 2t. We also need to find x, so we are going to use the first row over here. That's going to be x minus 3y minus 2z is equal to 9, and x minus 3 times y, or y is t, minus 2z, that's -2 minus 2t, is equal to 9, and this will become x minus 3t plus 4 plus 4t is equal to 9. -3t plus 4t is just plus t, and I'm going to subtract both sides by 4 to get 5, and finally x, subtract both sides by t to get 5 minus t. And I'm going to put that over here. I'm going to get 5 minus t, and that would mean that our 3 planes are going to be intersecting at the line above. So this is the equation of the line at which these 3 planes actually meet. Okay, note that in this question, whenever we have 3 planes that are meeting at one line, there's 2 possible situations. In one situation, we can have 2 planes being coincident, so just on top of each other, and the other plane is just intersecting them at that line. Or we could just have 3 planes being very different and intersecting at a line. So which situation is this? To figure that out, we need to figure out if any of these planes are coincident with each other. And in order to do that, we need to figure out if they're parallel, and also have any points that they share. So let's look to see if any of these are parallel. That's the first test. So to figure out if things are parallel, we can check their normal vector and see if they're scalar multiplication of each other. So in this case, to get from x to -x, we multiply by -1, but -3 times -1 is 3 and not -11, so these two are not parallel. From here to here, we multiply by 2. If we multiply the coefficient of y by 2, we will get -6, so these two are not parallel. And for these two, I have to multiply -1 by -2 to get 2, and if I multiply -1 by, or -2 by -11, I will not get +8. So that means these are also not parallel. That means that none of these are coincident, and that means the 3 planes are distinct and that they meet at the line. So we can write that none of the planes are coincidence. And that kind of completes our answer. We know where they meet, and we also know that they are no coincident plane, and that they're all 3 distinct planes meeting at that line. For our second part of the question here, we're going to use the same method as we did in the last question. So we're going to start by augmented matrix, and we're going to have our coefficients here, 1, -1, 2, -1, -3, and -2, and we got 1, 1, and 2 here, and we got 8, 2, and 11. We can go ahead with the first step. We're going to try to reduce these two values to 0. So for the second row, in order to do that, the easiest way is to add the first row by the second row because 1 plus negative 1 will be 0. I'm going to keep the first row to be the same, and for the second row, I'm going to say it's equal to row 1 plus row 2. 1 plus negative 1 is 0. Negative 1 plus negative 3 is negative 4. 1 plus 1 is 2. And 8 plus 2 is 10. And this is actually nice because we can reduce everything here, divide them by 2 to simplify this a little bit further in the next step. For the third row over here, I'm going to try to reduce this value to 0, and one easy way is to add 2 times negative 1 to 2, and that will give us a 0. So I will take, for the third row, I'm going to take 2 multiplied by row 2 and add it to row 3. By doing that, I will get negative 2. I'm just going to multiply everything in row 2. Negative 2, 2 times negative 3 is negative 6. 2 times 1 is 2, and 2 times 2 is 4. And we are going to add to that, and we are going to get negative 2 plus 2, negative 2, 2, and 11. So for our answers here, negative 2 plus 2 is 0. Negative 6 plus negative 2 is negative 8. 2 plus 2 is 4. And 4 plus 11 is 15. For our, usually this is our last step here, so I'm going to keep the same row 1. That's not going to change. And for our second row, just to simplify it a little bit, I'm going to divide row 2 from the last step by 2, and that's going to, or let's do it by negative 2 actually, and that's going to give us positive 2, negative 1, and negative 5 here. And for row 3 here, I want to try to get this value to 0, so I'm going to look at the lowest common multiple of these two values, that's 8. And I have to multiply this one by 2, so 2 multiplied by R2 from previous step. And in order to reduce this to 0, I have to subtract the 2. And if they have the same sign, they need to be subtracted. And I'm going to subtract that by R3 from the last step. Okay, I'm going to multiply everything in the second row from last step by 2, so we're going to get 0, negative 8, 4, and 20, and we're going to subtract those from R3, which were 0, negative 8, 4, and 15. And when we do this, we get 0 minus 0 is 0, negative 8 minus negative 8 is 0, 4 minus 4 is 0, and 20 minus 15 is 5. In this case, we can see that our last line here says that we get 0, 0, 0, and 5. So that would mean that 0x plus 0y plus 0z is equal to 5. But this is really impossible. It is impossible because if we put any x, y, or z value here, we will get 0 plus 0 plus 0 is equal to 0. And this is just an impossible thing, and therefore this cannot happen. Therefore, the planes do not intersect at a common line or point. To be more precise about our solution, because whenever there is no intersection, there's actually 3 possibility. It could be that all the 3 planes are parallel to each other, and that means they don't intersect. But that's not the situation. If we have that situation, we would have 0, 0, 0, a number here, and we would have 0, 0, 0, and a number here. But we don't have the 2 zeros here, meaning that they're not all parallel. The other possible situations, one would be that we have 2 two planes that are parallel and one is intersecting them, so they actually intersect at two lines, or it could be one in which we have three planes that are just intersecting at three different lines. So which one is it in this case? We have to look at our equations and look to see if any of them are parallel. If any of them are parallel, then it could be this situation, it will be this situation, and if there's nothing that's parallel, it will be this situation. So let's check to see if any of the normals here will be a scalar multiply of one another. In this case, when we see from here to here, we multiply by -1 to get negative x. If we multiply by -1 here, we will get +1, but that's -3, so these two are not parallel. Comparing 1 and 2, so I'm going to label this pi1, pi2, and pi3. We can see that pi1 and pi3, here coefficient 1 times 2 is 2, -1 times 2 is -2, and 1 times 2 is 2, meaning that pi1 and pi3 are parallel. So we can write that pi1 and pi3 are parallel, and that's because we got normal of 1 is equal to, or normal of 2 is equal to 2 times normal of 1, and that makes them parallel. And therefore the situation that we have is this situation. So we have two parallel and one intersecting. And really that is the main relationship between the planes. We know that these two are parallel, and this one over here, pi2, is intersecting both of these two planes. For our third example here, we are going to use the exact same ideas we did before. We are going to try to use three matrices to reduce it to echelon form. And right here, I can start by writing this one here first, but I want to reduce this one, and I like having round numbers on my very first one, so I'm going to right away switch some rows, and I'm going to move this row to the beginning, and I'm going to bring this one to the end. But I'm not going to write the operations for that. You don't have to when it's just in the very first step. So starting off with this one, this is going to be my pi1, pi2, and pi3, and those are going to be my rows. So I will have 1, -1, -1, and 5. For the second one, -1, -1, -1, and -1. Could just change all of that to positives, but it doesn't really make a difference. And for row 3, I will have -5, 1, -2, and -17. This is nice because I can easily reduce the second one by just adding row 1 and row 2. I'm going to keep my row 1 here, and row 2 is going to be row 1 plus row 2. And adding those rows up, 1 plus -1 is 0, -1 plus -1 is -2, -1 plus -1 is -2, and 5 plus -1 is 4. This is nice. Right away we can see that everything here can be divided by 2, so we can do that in the next step. But now we need to reduce the value here. The common, or the lowest common multiple between these two is 5, so I'm going to multiply my, so for row 3 I'm going to multiply my R1, row 1 by 5, and row 2 can stay the same, and they have opposite signs, so I will need to add them in order to get a 0. So for row 3, 5 times R1, I'm going to have 5, -5, -5, and 25. And I'm going to add row 3. I should have said row 3 here. apologize. Row 3 is going to be -5, 1, -2, and -17. Okay, now 5 plus -5 gives me 0, -5 plus 1 gives me -4, -5 plus -2 is -7, and 25 plus -17 is 8. Okay, this is good. I'm going to do my next step, 1, -1, -1, 5. For the next one, for row 2, I'm just going to reduce it a little bit so that I have easier values to deal with at the end. And divide everything by -2. So I will have 0, -2 divided by -2 is +1, +1, and 4 divided by -2 is -2. This is excellent. Now for row 3, I'm going to have it so that I'm trying to reduce this to 0, and I have to use this one because we got the zeros and zeros here. So the lowest common multiple here is 4, so I have to multiply second row here by 2, and that's going to be from the previous step, and not change row 3. And because they have the same sign, I have to subtract them to get 0. 2 times row 2, I'll do the calculations in purple here. We got 2 times 0 is 0, -4, -4, and 8. And we're going to subtract row 3, which is 0, -4, -7, and 8. So 0 minus 0 is 0. -4 minus -4 is 0. -4 minus -7, that's 3. And 8 minus 8 is 0. Now we have everything in echelon form. We have the zeros in the bottom left corner. So we're going to start off with the very last row here. And before actually going there, since we don't have all zeros here, and that means that we are going to have 1 point of intersection. So all of the 3 planes are going to intersect at 1 point. So in this case, we get 3 times z is equal to 0. Divide both sides by 3, so we get z is equal to 0. Then we are going to use the next row over here, and in this one we have 1 times y plus 1 times z is equal to -2. That means y plus 1 times z, which is just 0, is equal to -2. That means y is equal to -2. Nice round values. It's really nice to have. And finally, for the very first row here, we are going to use that. And we are going to have 1 times x minus 1 times y minus 1 times z is equal to 5. That's x minus y, which is -2, minus z, which is 0, is equal to 5. That's x plus 2 is equal to 5, and that's x is equal to 3 when we subtract both sides by 2. And since we have a nice solution, which is a point here, we can say that the 3 planes intersect at point. The x value is 3, the y value is -2, and the z value is 0. And this is our final answer to this one. In our last question in this video, we have to determine the value of k for which the planes will intersect at a line. And we have 3 planes here, and this k value is unknown, and we know that they are going to meet at a line. We'll start this off by writing it in augmented matrix form. So we're going to have the coefficients 1, 9, -5, and 0. -1, 2, 1, and constant of 0, and coefficients k, -1, 1, and constant value of 0. Once we have this, then for this augmented matrix, in order for the three planes to have an intersection in a point, that means that since this is already 0, that means these three values also need to be 0. So the goal is to make these two 0 first and figure out for what value of k it would also be equal to 0. So let's start this off, and what I will do is I will keep the first one as is, and I'm not going to change this one. For the, let's do the third one first. My goal on the third one right now is to make either this or this one equal to 0. And one easy way of doing this is just subtracting row 2 and row 3, because the 1 and 1 cancels out to equal to 0 there. So I can write this as either R3 minus R2 or R2 minus R3. I'll write it as R2 minus R3 for this. And then I will have k minus negative 1, which is k plus 1. I will have negative 1 minus 2, which is negative 3. And I will have 1 minus 1, which is 0, and 0 minus 0, which is just 0 here. So that is very nice, because already one of these values is equal to 0. I will need to change this to 0 in the next step. But to do that, I also need to make sure that one of these, either the first row or the second row, has a 0 value here. Because if I want to add or subtract anything in this row, between these rows, if I were to add something that had a value here, this will change back to a value, but I do need to keep it at 0. But if I have 0 here, for instance, then 0 plus 0 or 0 minus 0 will end up giving me 0 for this one, and I can do something with this. So what I want to do here then is to also make this value 0. So what I will do is I will find the lowest common multiple between these two values. That would be 5. So R2 here will equal to R1, and I need 5 times R2. And in order to get 0 right here in the third column, I will need to add the 2. So I will do plus. Okay, now I have these. I'm going to write all of the values down here. So R1 is 1, 9, negative 5, and 0 at the end. I'll just leave it in here. And I'm adding 5 times R2. So 5 times R2 for the first one is negative 5. 5 times 2 is 10. And 5 times 1 is 5. And this is going to be 0. So this is going to be 1 plus negative 5, that's negative 4. This is going to be 19, and this is going to be 0 and 0. So I will have negative 4, 19, 0, and 0. This is good now. I already have this value as 0. If I make this one also 0, then I can just solve for k here and figure out what possible k value will give me that. So to do this now, I'm going to keep the first row as is. So it's going to be 1, 9, and negative 5, 0. The second row isn't going to change. We don't really care too much about it at the moment. But for our last row, we are going to figure out how we're going to make this one equal to 0. So we're going to look at these two coefficients, and a lowest common multiple for these two will pretty much be 57, which is 3 times 19. So in order to cancel that term out, for the new R3, our new row here, is going to equal to 3 times row 2 and 19 times R3. And in order to cancel them out, because they have opposite signs, one is positive and one negative, we have to add them. So I'll do the additions on this side over here. 3 times R2, I am going to have 3 times negative 4, which is negative 12. 3 times 19, which is 57, 3 times 0, 3 times 0, and I'm adding that to 19 times R3, so that's going to be 19 times K plus 1, 19 times -3, which is -57, and I'm going to have 0 and 0 here. So I'm going to, just because this is not expanded, I'm going to expand it. I'm going to have this as -12 plus 19k plus 19, and this also simplifies further. This is going to equal to -12 plus 19, which is going to be 7 plus 19k. So I'm going to write that in for my first one, 7 plus 19k. For my second coefficient, I'm going to have 0, and for the last one, I'm going to have 0. Now, to have a line here, to have the intersection of all these three be a line, that means all of this row has to equal to 0. So that means we already have the z component equal to 0, or the coefficient of z. Coefficient of y is 0, so coefficient of x also needs to equal to 0. Therefore, 7 plus 19k need to equal to 0, and if I rearrange for this, I will get 19k is equal to -7. This is by subtracting 7 from both sides, and by dividing both sides by 19, I will get that the k value is equal to -7 over 19. And that is my final solution for this one. And that means that if the k value here is -7 over 19, then these three planes will meet at one line. I hope that this video was helpful in giving you some practice with the intersection of three planes, and it takes a lot of practice to get good at these, so just keep practicing and you'll become better and better. Thank you for watching.